affected, and the people who were affected fell into a profound sleep. They slept 20 or more hours a day, and they couldn't be aroused. A small subset could never go to sleep and was hypervigilant. Many died of this disease. It's an infection of the brain. And then this clinician, von Economo, discovered that what gets affected by the disease are two parts in the brain that are specifically responsible for promoting consciousness and for promoting sleep and awake. So ever since him, we now know that sleep is an active state and that there's a switch that has to be turned on in order for me to be conscious. So it's just like my heart has to operate in order to get blood through my brain, but also in terms of brain stem, there are neurons in the brain stem, in the part of the brain and the lower stem, that have to be active for me to be conscious. But they don't themselves generate conscious experience, but they have to be present in order and for there to be conscious. So now what the modern search for what people call the neuronal correlates of consciousness is, the idea is I'm looking at something like that scene with a dog, and I like to identify what are the specific mechanisms in my brain that give rise to that conscious experience compared to when I don't see the dog. Is it a particular type of nerve cells? Are they located in a particular type of brain? How does it differ when I see something versus when I imagine the dog, or when I dream about my dog, or when I smell a dog, or when I'm upset? What is the commonality among all these different mechanisms that give rise to consciousness? Because we care a lot about mechanisms, and so we're interested, what are the specific mechanisms that give rise to any one conscious experience? And so we have sophisticated techniques. This is, for example, one technique. You're looking at the picture on the left, and you can sort of see a face, right? Now, when I briefly flash this image, sometimes you can see a face, and then you push a button, yes, I see a face. And sometimes you don't see a face. The image is always the same, but because it's flashed so briefly, only sometimes do I have a conscious experience of a face, and sometimes I don't see. All I see is noise. And so I can now look at the difference in your brain to try to identify where the specific areas in the brain that are associated with having the conscious experience of a face. And this is what many labs do now. Why? Well, because we'd like to look at what is it about the specific, which bits and pieces of the brain give rise to consciousness. We know this is a remarkable finding. So this is a patient who has a big hole in her brain. She lacks the part of the brain called the cerebellum. You know, there's a little brain at the back of the brain. In fact, 69 billion of your 86 billion neurons are in this little brain called the cerebellum. More than 4 to 5 neurons in your brain are here. If you're not born with them, early on you have more difficult to learn, early on you have more difficult to speak, but once you're adult, it's very difficult to tell the difference from a normal person, and this person doesn't complain. She has perfectly normal consciousness. And we also know from other cases when you have a stroke in the cerebellum or when it has to be operated upon that the cerebellum does not give rise to conscious sensation. So this is very interesting if you care about mechanisms, because it says, well, those are neurons, they have all the electrical activity you expect of a neuron,